Question 3 deals with electric circuits, and the first part is about potential difference or voltage. Key thing to remember here is that the words voltage and potential difference are pretty much interchangeable as far as these questions are concerned. So when you see voltage, you can think potential difference. When you see potential difference, you can think voltage. Okay, so some key points at the top that if you don't read make the question very difficult. The lamps in the circuits drawn below are all identical. Each of the cells has a potential difference of 1.5 volts. Now a cell is a single one of these symbols here. So the left-hand circuit has one cell. The middle circuit has two cells, and the right-hand circuit has three cells. So the first question, what is the potential difference across the three cells that are joined in series? Well, provided those cells are facing in the same direction, all you have to do if they're joined in series is add the potential differences together. So it's 1.5 times 3 for the three cells, giving us 4.5 volts. What will be the reading on the voltmeter labelled V3? Well, the rule for potential difference is that the electrons, basically the charges, flow through the cells and gain energy from them, and they will gain 4.5 volts flowing through those cells. And when they flow around the circuit, they have to get rid of those 4.5 volts in the components. Now, if the bulbs are identical, then that voltage will split evenly between the two components. So half will go on this bulb and half will go on that bulb. That means the V3 voltmeter will read half of the 4.5. And if you put that through your calculator, that will give you 2.25 volts for the voltmeter reading for V3. You got that mark even if you got the first part here wrong, provided whatever you put for your answer for 3A part 1, you put half of it in 3A part 2. Now, which voltmeter V1, V2 or V3 will give the highest reading? Well, the easiest way to do this here is just to work out what the individual voltages will be. We already know that V3 is 2.25. If we have a look at V2, well, that has two 1.5 volt cells, so that 3 volts from the cells there, and the only place to lose that voltage is across the bulb here. So 3 volts from the cells means 3 volts across V2. So V2 is certainly higher than V3. It's 3 compared to 2.25. And if we look at the left-hand circuit, well, it's very similar to the second one, the middle one here, except that there's only one cell. So that one cell will provide 1.5 volts. There'll be 1.5 volts across this bulb. So that one's lower than either of the other two. So the highest is going to be V2 with its 3 volts. Next part. So it's moved on from talking about voltage to looking more at resistance now. Calculate the total resistance of the two resistors in the circuit. Well, there are the two resistors, the 10 ohm resistor there and a 20 ohm resistor there. And for resistors in series, you just have to add them. So that is simply 10 plus 20, giving us 30 ohms. Use the equation in the box to calculate the reading on the voltmeter. Well, here's a case where you've got to remember that voltage and potential difference are the same thing, effectively. So the reading on the voltmeter will be the potential difference. So we need to find the information. Well, the resistor we're looking at is the 20 ohm resistor, so that means the 20 ohms will go in for resistance here. Now, what is the current? Well, this is a series circuit. There's only one loop around. The voltmeter doesn't count as a loop, by the way. All it does is read the voltage. You can ignore it for the purposes of any current flowing down it because it has a very high resistance. So the current will flow through here. Now, there's only one way for it to flow, so if there's 0.4 amps here, it will be 0.4 amps everywhere in the circuit. Okay? And that means that the current through the 20 ohm resistor will be 0.4 amps as well. So we have 0.4 amps multiplied by 20 ohms, giving us 8 volts. Okay? 1 mark for the correct substitution of the numbers, and 1 mark for the correct answer. It does also allow 1 mark for answers of 4 or 12. That's basically if you use the total resistance by accident, or if you used the 10 ohm resistor by accident. Okay, and finally, it's asking you to remember some current voltage characteristics for different components. You just have to learn the shape of these graphs. The current through a resistor at constant temperature changes when the potential difference across the resistor changes. Which graph shows how the current changes for a resistor? Well, the resistor is the simplest one. The resistor is the straight line. Okay, so that is graph Y. You just have to learn that. Graph X, by the way, is a diode, and graph Z looks more like a bulb. The bulb current doesn't increase as rapidly when you increase the potential difference. So Y was the answer there. That was the only option.